When we want to change slides, should we just
Mm-hmm.
ask you like we did the first
Yeah.
time?
Mm-hmm.
Okay.
That's fine.
All right, it's recording.
Okay. Okay. Hello, everyone. Thank you for joining us. We are Group 11. My name is Kyra Bernard. Everybody else can introduce themselves.
I'm Jorge.
I'm
Mm-hmm.
Riley.
I'm Daniel.
Mm-hmm.
And I'm Colby.
Yes, so we are Group 11, and this is our presentation for our engineering design main project. We have created the application, are currently working on the application Aperture, which is a privacy preserving sharing content and situational awareness control application. So our problem, okay? Millions of sensitive documents, images, and messages are shared every day. Currently, there are several applications that provide encryption during transmission. Of course, like we know, things such as WhatsApp, but those applications can only do so much. They provide encryption only during transmission. Without protection, senders lose control over their content after it is sent. The loss of control then causes privacy and security concerns. Some concerns may include HIPAA violations, social security exposure, financial information exposure. Our biggest goal is to offer people protection of their sensitive content and information. So our application, Aperture. Our solution is Aperture. Aperture is a software application that focuses on privacy, preserving content sharing. This application was built to have content uploaded, encrypt the content, and have a sender set conditions for viewing. These requirements are intended to protect the sender's sensitive information. The user is able to upload documents, images, and files to the application. The sender is required to define conditions. These specific terms must be met before viewing. Continuous monitoring for violation is enforced to prevent content breach. The situational awareness mechanisms work to monitor the viewing area. The environment should meet the standards set by the sender. For example, if the sender has set a condition to only allow one individual into the viewing area, that condition must be met. The system will also monitor for any external devices like a cell phone trying to take pictures of the restricted content. Of course, in order for our system to work, we must set requirements to make sure the application can provide the most security when sending content. Requirements are set up and built upon. Verify credentials is an important one, which helps to manage a user's account and saves their uploaded content. The system shall require users to upload content. A user can upload content. This content shall be encrypted and is the main component of the application. The uploaded content shall be encrypted before storage. Encrypting the content before storage prevents data breach. If storage is breached, this allows the content to be unreadable. The system shall allow users to select recipients to receive content. Users are able to then determine the recipients of their choosing. The system shall automatically restrict view of content if conditions are violated. Viewing conditions must be maintained throughout the entire viewing session to enforce protection. The system shall return the viewing rights to the recipient once conditions are met. Again, once viewing rights have been restored, the system will continue the viewing session. The system shall allow users to set restrictions for viewership. This, of course, is the main important thing. This allows for senders to have more control over their content being shared and who views it. The system allows the user to define their own conditions. These conditions will be used and enforced to maintain privacy of content. These conditions allow for the sender to maintain control, and the system shall monitor the viewing environment continuously. Situational awareness control will monitor the viewing environment. Environment terms should be defined by the sender. And of course, we have usability and security. The system is to be completed to work as a user-friendly application for private content sharing. The system will give notification of access granted, access suspended, or access revoked. This gives users awareness of condition status. The system performance should be not interrupted. The system shall allow users to upload content within 10 seconds. Security measures that we are going to try to enforce will be the system is constructed to require authenticated users access. Personal information shall only be accessible to authenticated users, and the system shall maintain audit logs. Audit logs will help keep history of what went wrong and who did what. This allows for records of system events. Next, I will pass it over to Riley.
Hi. Now we're going to focus more on Aperture's system level design. We chose a client server architecture because the client applications should provide the user experience while the backend remains responsible for the sensitive security decisions. This overall reduces the risk of someone bypassing restrictions by modifying their device. The backend will receive the information from the user on the current conditions, and it will evaluate them against the sender's policy for that content and return an access decision to the application. And we also chose to separate the encrypted files from the other data, like user accounts, viewing policies, sessions, and audit logs. And this limits how much information could be exposed if one part of the system were compromised. And overall, the architecture creates a clear boundary between what the user sees on their device and what the trusted backend controls. Next slide, please. And this diagram shows the flow of information through Aperture. At the top, the sender uploads the content, selects the recipients, and defines restrictions through the client application. The recipient also uses the client application when attempting to open the shared content. The arrows show that content is not released immediately. When the recipient submits a viewing request, the system first verifies the user and retrieves the sender's viewing policy. Access Control and Monitoring subsystem then compares that policy with the recipient's current conditions. Only after those checks pass does the content management retrieve the approved encrypted file for viewing. And we can move on to the next slide. So we divided Aperture into separate subsystems so that each part has one main responsibility. This design allows different team members to work on different subsystems at the same time. It also makes the system easier to test. For example, the authentication subsystem can be tested independently before it's connected to content management. Once the individual components are working, they'll be connected through defined interfaces and API requests. This separation should make errors easier to locate and allow for one component to be improved without having to redesign the entire application. And we can move on to the next slide. So I'll be responsible for handling the designing of the mobile client application. We plan to develop this with Flutter so that both Android and iOS can share most of the same code base while still using platform-specific features when necessary, like for screenshot detection, for example. Some of the functionalities of the application are that senders need tools for uploading content, choosing recipients, setting conditions, and managing or revoking access. Recipients need to review shared content, see which requirements must be met, and securely open the content after approval. The mobile app will also collect supported contextual signals, including location status, biometric results, device information, and screenshot events. However, it will not make the final authorization decision. It sends this information to the backend and follows the backend's response. And we can move on to the next slide. Thank you. So the mobile interface is designed to make complex security settings understandable to a normal user. After logging in, users will see a dashboard separating content that they shared from the content that they've received. Senders will move through guided screens for uploading a file, selecting recipients, and configuring restrictions through familiar controls like switches, menus, or date and time selectors. Recipients will see the requirements associated with the file before attempting to open it. The interface will clearly indicate which conditions are satisfied and which still need attention. And if access is denied or suspended, the application will explain the reason instead of just showing an error. And we can move on to the next slide. Oh, thank you. Okay, so the mobile application will be implemented in phases. First, I'll set up the Flutter project and develop the basic navigation and screens. The next phase will connect those screens to the backend API. And then after this main communication is working, we'll integrate the mobile device features like location services, biometric authentication like Face ID or fingerprint, the camera access, secure storage, notifications, and screenshot handling, where each operating system supports them because it'll be different depending on the operating system. And finally, the application will be tested on real devices. Testing will include successful access, denied access, policy violations, revoked access, expired content, API errors, and differences between the platform capabilities. Alrighty, and we can move on.
All right, so moving forward into the desktop app user interface, it will be very consistent with the mobile interface. It'll offer the same user login, account control, the same support for sending and receiving content, all feature support as far as restrictions and other components go. And just like the mobile application, it's going to have its decision making determined by the API rather than the client itself. Like the mobile app there's going to be separate flows for senders and receivers with the same notation used on the mobile app to represent them. The differences between a mobile app and the desktop application will basically be just the button layout and how much is actually presented on a single screen at one time. The reason for this is desktop screens are simply just larger. You could take advantage of more screen space being present, and overall just shorten the overall navigation between different pages to get some process done. After logging in, the user is going to be presented with both the available content that they have been invited to view, as well as have the option to send or view content that they have already sent on this page as well. Selecting any option regarding sending or receiving content will bring the user to its respective page. If the user were to select to view content that they've received, the application will display all the available invites, and if you were to select further, it will further display the restrictions required to view that content, and whether or not they are satisfied. Just like the mobile app, it will prevent error. It will show a error that is actually readable and understandable, telling you what the issue is, rather than just a generic "something went wrong" message. Selecting to send content will give you the same results as far as viewing what restrictions are available. You will also be able to view the users that you'd like to send an invite to, and obviously upload the content that is to be shared. Doing this, you can also view the content you've already uploaded if you need to make changes to viewing restrictions or anything of that sort. And we can move on to the next slide. So for the implementation plan of the desktop application, like the mobile application, once again, it'll be developed in various stages, beginning with research, UI development, moving forward into feature development, and hooking to the actual backend API. Same general process. Once the desired application flow and result has been met, and the API can support this, we'll move on to the next feature, basically. So we would begin with, for example, the situational awareness, context awareness system. And once that's fully fleshed out, finished, we would move on to something like the location data or something else of that nature. As features are supported by the API, as it's going to make all the decisions, it's kind of going to be the bottleneck here. Once the features are supported by the API, the desktop client will begin development, testing, and so on and so forth with that specific feature. Testing phase will be done over and over with each new feature when created. And for the desktop application, it is intended to be used on Windows-based machines. And we can move to the next one. So for the web API implementation plan, it's going to be fairly similar as far as the stage development process. On the slide, you can see we have create a standard account system is just the generic. This is how we get started. Once we have that support and all applications can hook into it, we can then move forward and develop the actual features that will be used during the dynamic decision making. The API's main focus, obviously, besides being the deciding factor on whether or not you can or cannot view a file or any sort of data, will be also removing and reallowing the ability to view this data at a reasonable or quicker reaction time. First of all, like I said before, we would begin with creating the basic account control system. You would also be able to send and receive invites to the account that you're logged into. The information, all regarding accounts, content uploaded, anything like that, would be encrypted and stored within the content storage vault. Once the account system is functional, as said before, we can move on to adding support for various features across the different platforms. API, once again, will be the processing and decision-making engine, and it will be required to manage the state of access for each individual user currently trying to view content on the platform. The features, like I said before, will be added one by one, and we will create the feature, ensure it's supported on all the different platforms, test that feature. And the good news, or the good thing about having this sort of stack set up, is that we can see if, for example, if errors are found with the desktop application but not with the mobile application, we can almost positively chalk that up to a desktop application is sending the wrong info up, as we are getting the expected results on mobile. Now, if there are issues across all platforms, we can sort of point the finger at the web API here, considering it is the main control center for every platform. If there will be an issue, it should be reflected on all available platforms. This will make that debugging and diagnostic process much faster to figure out, and that way we can keep moving forward on feature development, and nobody will be blocked unless they are the root cause behind failures within the application. And we can move on to the next slide. So overall, as stated repeatedly, we're going to do that sort of stage development and testing cycle. It's going to be a very lengthy process of implementation for this, with a lot of moving parts that need to be synchronized. Each application on their respective platform is going to be receiving the same decisions from the API as they would on any other platform. So it's going to be a universal, generic kind of response that'll say, essentially, yes, you are allowed to view this content, or no, you are not allowed to view this content with a reason why. Our plan is to, like stated before, develop a basic account system, which would begin our stepping stone into the rest of the application development. We will be creating the features as stated. Once the feature is created and supported on all the application platforms, we can begin testing for that feature. Once testing has been completed, we can evaluate if anything went wrong, where it went wrong, why it went wrong, and then immediately task the responsible party for correcting that error. Finally, the database subsystem will also be developed in tandem with the web API, basically adding tables and other necessary management systems as they're required by the API. We want to really reduce bloat in our application and our environment. So creating things in the database just as they're needed and only for the reason that they're needed is kind of vital here. And that's all for me.
Thank you. So camera-based detection and screenshot prevention. So I'm responsible for the camera-based detection and screenshot prevention subsystem. So this exists just to close the gap that most privacy tools have. Once content is decrypted and on the screen, most systems, they just don't or cannot stop someone from capturing it with either like a screenshot from the system itself or with a picture that someone took on a different device. My subsystem catches that second case. It works alongside our mobile context collection components and is constantly watching the viewing environment. And if it detects a capture attempt, it reports it to the backend, and it doesn't make any cross decision by itself. It reports what it sees, the backend decides. I'm building that with the OpenCV and Google Media Pipe. Next slide, please. So why camera-based detection? So I want to explain why we designed it this way. When I was researching this for our literature review, the pattern across existing tools was consistent. Apps like WhatsApp and Signal, they protect content in transit, but once it's opened, the sender has no control left. Even Microsoft's Purview information protection, which lets you set an expiration date and revoke access, they only check the conditions when a file is opened, but not continuously. And none of these tools catch someone physically capturing the screen with a second device. A 2025 study actually published through the ACM confirms the gap and shows real-time camera-based detection, and is actually possible, but only if it's fast enough. That's exactly why our sponsor made detection latency one of our core requirements. It's just not one of those nice to have features. It's very important. Next slide, please. So security, layered, not single point. So security here isn't just a single control point, it's layered. Content stays encrypted until every condition the sender set is actually confirmed, not just when someone opens the app. Passwords are hashed, never stored in plain text. Access decisions live entirely on the backend, never the client. Because of that, if the logic lived on the device itself, someone could potentially modify the app to bypass it. And it's not a one-time check at login. The system keeps reevaluating, and the whole time content is being viewed. So if something changes mid-session, including my subsystem detecting a capture attempt, access gets suspended immediately. We treat a false positive, wrongly granting access, as more serious than a false negative, because it's a direct privacy failure. Next slide, please. So camera detection roadmap. The plan follows the same staged approach the rest of the team is using. So first, research, evaluating OpenCV and MediaPipe approaches, plus screenshot detection limits across platforms, especially iOS. Then building the actual detection pipeline and connecting it to backend reporting. Then a dedicated latency testing phase kept separate from general functional testing, because this is for the subsystem speed. A detection system that's accurate but slow doesn't actually solve the problem. Testing continues as features get added through development. Next slide.
Thank you. My part is the situational awareness control, which evaluates sender-defined conditions before granting access to shared content. So instead of a one-time login check, every time someone tries to open the shared content, we run it through a set of conditions that the sender configures when they share it. Some of these conditions include the location, the time window, the device authorization, biometric verification, and environment requirements. Like for example, you can make it so it's only viewable from a set location, only available for like a set amount of time like other systems have, and available on a specific device, just like many systems so far have developed these, but we're putting it all together, and like previously stated, we're making sure that it will constantly be rechecked. And this also works alongside access policy management and access control with all of these monitoring subsystems that we have. and this denies access with a specific reason when a condition is not met. So the user isn't just told access denied, they're just told exactly why, like you're outside the permitted location. So it's clear what needs to be fixed for these conditions to be met. Next slide, please. So for the situational awareness control, this is the implementation approach. The access policy model defines sender configured viewing conditions. This is the underlying data structure. It's what actually stores the location, time window, device list, and everything else the sender picked. And then the condition evaluation logic checks a recipient's current context against the policy. This takes the recipient's real-time information, like where they are, what device they're on, and compares it against the stored policy to make a grant or deny decision. And the continuous session monitoring rechecks conditions while the content is open. This is the part that makes it different from the normal login checks is, yeah, once again, like I said previously, it keeps checking as long as the content stays open to make sure that all the conditions are met at all times. And it automatically suspends display when a condition is violated, and it restores it once it satisfies again. Next slide, please. Key considerations with the situational awareness control is balancing real-time condition evaluation with minimal performance impact. Rechecking conditions constantly takes a lot of data, it's very powerful pretty much. But if we check too many times, it can drain the battery or slow the app down. So we need to be careful with how frequent we do it. So our system will develop it to be as efficient as possible, and coordinating with access control and monitoring to avoid duplicating enforcement logic. This is a note, or sorry, the monitoring logic needs to stay in sync with the continuous access evaluation work, so we don't end up with two systems that enforce the same thing but in a different way. And designed to integrate with backend API endpoints for policy configuration and access decisions. From the start, we built this to plug into the backend rather than run it as something that just stands alone on the client. Next slide, please. And then the API integration and testing, it sends the recipient context like the location, the time, the device ID, and captured on the client to the backend for evaluation. The client's job is just to gather that information, pass it along. The actual decision happens on the backend and receives an access decision from the backend, which if denied, the specific condition was not met. And like I said earlier, it goes into it and explains why the condition was not met. And in order for the access to be granted again, the condition needs to be remet. My scope is the condition evaluation logic itself, not the API endpoints or the account session handling built by the API team. So I will be developing to make sure that anytime any of these conditions are not met, that the access will be denied, and to make sure that these conditions are always there. And the testing plan is to validate each condition type independently, then verify, suspend/restore behavior during an active viewing session. Thank you.
So these are all of our resources and references. And we just want to stress again that our main point of this application is to provide privacy and secure content sharing with situational awareness control. On behalf of Group 11, we thank you for listening to us and have a great day. You can stop recording, please.